You have a standard DC motor that spins thousands of times per minute. But how fast is it really going? This is a Hall sensor. It's a tiny sensor that uses invisible magnetic fields to tell you the motor's true speed. And today, I'll show you exactly how to build one. Before we even get the motor involved, let's see how this thing works with the simplest circuit you can imagine. You'll only need a Hall sensor, a small magnet, an LED, a power supply, and an Arduino. The wiring is as follows. Connect the Hall sensor's VCC pin to the 5V on the Arduino, the GND pin to GND, and the signal pin to D2. Connect the longer leg, which is the positive side of the LED, to a digital pin on the Arduino, for example, D6, via a 220 ohm resistor. The shorter leg, or negative side, goes to GND. Let's write a simple sketch to make all of this work. First, we define the pins where the components are connected. Next, in the setup function, we configure the LED pin as an output and the sensor pin as an input. In the loop function, we set the state of the LED to match the value the sensor provides. Now watch this. When I pass the magnet by the sensor, the LED flashes. Each pass creates this pulse. We've just converted an invisible magnetic field into a flash of light. This is the exact pulse we'll use to measure the motor's speed. Thanks to this mini project, we'll learn which side of the magnet the sensor reacts to. I recommend marking it with a marker so you don't forget. Okay, next we need to assemble the actual physical setup. The whole idea is to get a magnet to spin with the motor and position the sensor in the right place to see it pass by. First, grab a small, strong neodymium magnet and attach it to the motor's shaft. You can glue it to a small wheel or simply glue it directly right there. The only thing that matters is that it's securely fastened and won't fly off when things speed up. Then you just need to position the Hall sensor so that the magnet passes by it on every revolution. It needs to be close enough to trigger, but obviously not so close that it crashes into it. I used a small amount of double-sided tape to hold my sensor steady, but you could use hot glue. The main thing is that it doesn't move. In the full project, all of our data will be displayed on an OLED screen. The Hall sensor has 3 pins: power, ground, and signal. Power, or VCC, connects to the 5V pin on the Arduino. Ground connects to any of the GND pins, and the signal pin connects to one of the Arduino's digital pins. I highly recommend using pins 2 or 3 because they support something called hardware interrupts, which will be key for getting a reliable count. Connecting the OLED display is also simple. We connect SCL to the 5th analog pin on the Arduino and SDA to the 4th. We also connect VCC to 5 volts and GND to GND. In the firmware, you can select the display mode. Depending on what you set, the data is displayed differently on the OLED screen. Mode 0 shows the speed in revolutions per minute. Mode 1 shows the speed in kilometers per hour. Mode 2 shows the speed in meters per second. You'll also need to add the diameter of your wheel to the code. Now, let's power this thing on. I'll slowly start the motor. Immediately, our OLED display shows a number. That's what this is all about. Thanks for watching, and I'll see you in the next one.